Welcome, and we are doing video 2 on the lesson 6.1 and 6.2 from pre-calc, dealing with law of sines and law of cosines. So what I have here in video 2 is, remember that we had talked about the law of sines and the law of cosines, the formulas, and these are the formulas in which we're looking at. Just a reminder, there was two ways to look at the law of sines, one where the angles are in the denominator, the other where the sides are in the denominator. And depending on whether we're looking for a side or an angle, we would choose one form or the other. For example, if we're looking for C, we're going to prefer to have C up on top, so I would use this system here. The law of cosines, the reminder is whatever side I am looking for, like a squared here, then I have the angle cosine A. So every piece of information in between is bookmarked between those two. The b squared plus c squared minus a 2bc. So notice that again that happens with the b and the b squared. Now we can use this formula to solve for an angle such as angle B, but we may want to rewrite it as follows. So we have the two possible ways of rewriting for finding cosine B. But otherwise, just work it as it was, and that's normally what I do, and then just bring things over as you need them. So let's look at a couple examples. We'll look at a few examples on this page, I think 3, and give you 2 to try, and then we'll look at a few more examples on video number 3. So let us begin. So in these examples, it says use the diagram. Notice it says not drawn to scale. Rarely are they. In fact, I think one time one of these is a obtuse triangle or an obtuse angle, and then it's hard to see, exactly what happens, or it's something that is larger than what they look like. So just really, this is used for reference to remind you that B opposite is little b, angle A opposite is little a, and angle C opposite C. Now remember, we're dealing with oblique triangles, so we do not have right triangles. Now we can find a case where there's right triangle, but normally that's given to us. So let's look at a few examples here. It says find the remaining sides. So what we're given is we're given an angle, angle A, angle B, and then a side. And that side has to be opposite one of those two. And in this case, it is opposite A. And so what I have is an angle side case scenario. Now you might recollect from the last video that that would mean we need law of cosines. So just take, law of sines. So just take a look at your notes and make sure that we're correct on that we're using the law of sines. Now, when working with this, notice that I'm going to then want to find what? Well, in this case, we're going to want to find side B. Now, because I'm trying to find side B, I'm going to want the letters or variables that represent the sides in the numerator and then the angles in the denominator. So what I mean by that is I'm going to try to find B, so I'm going to have side B over the sine of B, which is 30 degrees, and set that equal to the side A, which in this case is 32 feet, over sine of A, which is 45 degrees. So now all I need to do is multiply each side by sine of 30 degrees to get my variable B by itself. Or in some cases you'd think of just cross multiplying for this side only for sine 30. At any rate, when we put that into our calculator, we will find out that we get a value for B. So side B, its value to the nearest hundredth will be 22.63 feet. So we found one of the missing sides. Now, at this point, we're going to solve for C. So we still have angle C missing and side C. And this formula, you might say, hey, that's not going to work if I have two unknowns. But in truth, we can find one of those unknowns pretty easy given the two measured angles. Recall that any triangle, so the measure of angle C, any triangle will have 180 degrees. From that, we'll subtract our two angle measures, which in this case are 45 and 30. And when we do that, we find out that the measure of angle C for this problem will be 105. And of course, our triangle doesn't look like it has any obtuse angles, but again, it's just a reference for us. So if I have that, then I want to find my C, my side C. So it's going to be C over sine of 105 degrees. And I'm going to set that equal to one of the other values, either the A's or the B's. Now in this case, I'm going to choose the A's, and I always do that, not choosing the A, but the side that gives me both pieces of information without decimal approximation. So the given was that A was 32 and that the sine of A was 45. So I'll use that. I could have chosen to use B, which would have been 22.63 over my sine of 30 degrees. And that would have gotten me nearly the same answer, but it would have been slightly off due to a rounding error because I had already rounded this. So I choose to use the one I've been given. Working with this problem then, I will have C equals 32 times my sine of 105 degrees all over sine of 45 degrees. And in working that math, found out that that would give me a value of 43.71 feet. Now if I look at example 2, you'll see I'm given an angle, I'm given a side, and I'm given an angle. And in this case, when we look at the picture, we have an angle A, an angle C, or B, and an angle C, and that will give us the idea that this is in fact a slightly different problem because B is B is equal to 24. So we really have an angle and then a side and an angle. Now which one would we use? Either law of cosines or law of sines. In this case, we're going to use law of cosines. Okay, we're going to use law of cosines. Now, I'm going to erase my little picture, my little diagram, and make some room for the work. Now, when solving this problem, I am going to set it up with the B on the outside, so my B squared will then equal my A squared plus C squared minus 2BC times cosine of A. Now my B is given it, my cosine of B. Now my B is given, I'm sorry, how about I just erase that? I'm working with law of sines. I'm working with law of sines. For some reason I was thinking side angle side, which is cosines, but this is angle side angle. And I could see as I was setting it up, it was not working because I had two angles and I wasn't going to be able to use that formula. So that was a good example here of how you can catch yourself in a mistake. Again, this one is going to be a law of sines. Now, if I set this up, I'm going to have two of the angles, and again, I'm solving for a side here. And if I set it up with B in mind over sine of B, I can't do that one. But what I can do is have the knowledge that I have a missing angle. and that missing angle is B. But that, once again, would be my 180 degrees, and I'm going to subtract from it 52 degrees, and then subtract 47 degrees. That will leave me with 81 degrees for side, or the measure of angle B. So 81 degrees. Now, I'm going to leave the rest for you to do, but I'll set up the first part. And because we have B of 24, I'm going to use my sine of 81. And then I'm going to either solve for A or B. Let's solve for side A, which means we need the angle, so sine of 52. And that is one setup to solve. Then the other setup that I'd like you to work on would be to set up 24 over sine 81 equals, and then what do we get with a C over sine 47. So we got that set up. That's the good process for you to just work those out on your own. Now let's look at 3. Given A, B, and C, we're given all sides. Side, 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 which is, in fact, and this time I'm not going to misspeak, it is the law of cosines. Now in the law of cosines, I'm setting it up. It depends what angle do I want to find. Now I will always find the largest angle, and the largest angle is always opposite the largest side. The reason I want to do this is because cosine, when I use law of cosines, can give me the obtuse angle, where sines can't. Remember, the arc sine or the sine inverse falls in quadrant 1 or quadrant 4. But cosine falls in quadrant 1 or 2, and I'm able to obtain the obtuse angle. So I'm going to grab the largest side. And remember, there's not going to be 2 obtuse angles. There will be only 1. So I'm going to take 36 and square it, and that is going to be equal to my 28 squared plus my 23 squared minus 2 times 28 times 23. And that is going to be times cosine of C. Now remember, we had other formulas we could use for cosine C, but we know some algebra. So if I solve this, and I'm going to bring this all to the other side, I'm really going to have 36 squared minus 28 squared, subtract 23 squared, all divided by a negative 2 times 28 times 23. This gives me a calculator problem, and when I figure this out as the cosine C, I'm going to need to use my arc cosine, or my cosine of negative 1, so second cosine. Punch this in, just be careful what you're working with, and I get 89.2 degrees for the measure of angle C. Now I need to find out my other values, and my other values will be obtained from using the law of sines. Now when I'm using the law of sines at this point, I am going to make sure I use the smallest one, because that guarantees me an acute angle. And then I can just forget all that ambiguities test. I'll be set up. So here's what I'm going to do. I set it up as the sine of 89.2 over 36 equals my sine B, in this case, because it is the one opposite the smallest side, will give me the smallest angle. And when I work this out, I end up with a 0.638827 equals sine B. So once I do my sine inverse on this value, I get the following answer, that the measure of angle C equals 39.7 degrees. All I need to do is take 180 degrees, subtract that 39.7 degrees, subtract my earlier one of 89.2 degrees, and I end up with 51